you can see that the kinetic energy is first converted to rotational energy, which is a form of mechanical energy, and then using a rotor it gets converted to electrical energy. um, so before we understand a turbine, turbine is a form of a prime mover. So what is a prime mover? So a prime mover is a device which converts any available form of energy to the required form of energy that we want. So that could be anything. For example, an IC engine converts heat energy to mechanical work. So similarly, electric motor converts electrical energy to rotational energy. And similarly, turbine converts the kinetic energy to electrical energy. So yeah, so if the rotational motion is due to kinetic energy of steam, then it's called a steam turbine. And this is the classification among turbines. And then if the rotational motion is caused due to pressure energy of hot gases, it's called a gas turbine. And the third one is if the rotational energy or uh, the motion is caused by water, then it's called a water or hydraulic turbine. So a device which can convert potential and kinetic energy of water into mechanical energy, as I said, is water turbine or hydraulic turbine. And this is what we'll be mostly studying. And yeah, so let's move to the consistent parts of a water turbine. So it consists of a rotating wheel fitted with blades and stationary ring of guide vanes. We'll move to the drawing and then it will be much easier for you guys to understand. Then these guide vanes direct the water onto the pressure onto the correct angle, so that the water energy which hits the turbine at a particular angle, make sure it rotates, and then once it rotates, the rotational energy is then connected to a rotor, and that gets converted to the electrical energy. So that's the gist of the functioning of hydraulic turbine. So then there are many classifications of hydraulic turbines. So this is pretty important. So please make sure you know all the classifications. Um, so yeah, so first, based on action of flow of water, so that is impulse turbine and reaction turbine. That is the way in which the water is flown inside the turbine. And then based on the head available, that is how much of water is there above the turbine, whose potential energy is being converted to kinetic energy and then to the electrical energy. On this basis, it's classified into three methods. One is low head turbine, one is medium head turbine, and high head turbine. So the examples of low head turbine is a Kaplan turbine, medium head turbine is Francis turbine, and high head turbine is a Pelton Wheel turbine. Then based on the direction of flow of water with respect to the runner. Okay, so runner is the one to which the water impacts and then it rotates. So based on that, so there could be different directions of the flow of water. So one is tangential flow turbine. Second is radial flow turbine, that is Francis turbine. Tangential flow turbine being Pelton wheel. Then axial flow turbine being Kaplan turbine, and the mixed flow turbine being modern Francis turbine. So what it means is tangential flow turbine, as you would have studied in circles during your school time. So anything that hits the surface of a circle and crosses it only in one point, that is absolutely perpendicular to the direction of the radius or the diameter from the center to that point. Okay, that's called a tangent. So if the water hits the Pelton wheel at the tangential direction, which is why it gets classified as tangential flow turbine. Similarly, when the water moves in the radial direction, it's called a radial flow turbine, and if it flows through the axis of the runner, then that's called a axial flow turbine. Okay, then based on the position of runner shaft, horizontal shaft turbine and vertical shaft turbine, that is how the shaft is placed, whether horizontally or vertically. And this again is examples of Pelton wheel and Francis wheel turbine. Okay, so then let's move to the three important turbines that we will be studying in detail. So the first is a Pelton wheel turbine. And you can see the diagram here. It consists of a runner and the casing around it which protects it, and then the buckets into which the water is impinged onto it, which causes the rotation motion of the runner, and the water flows from the a high pressure reservoir through the penstock into the nozzle, and then it strikes the buckets of the runner, and this striking action causes the buckets to move in the rotational direction, which in turn makes the runner rotate, and this rotation motion is further converted to electrical energy, and the water after hitting the bucket flows down through the discharge water. Okay. As I said, I gave the brief explanation of the Pelton wheel. These things, as I mentioned previously, also the diagrams are important, and once you know the diagram, it's pretty much self-explanatory. The main thing is here the parts of the Pelton wheel turbine. I gave you in brief. So, runner is the disc on which the blades or buckets are fixed. And so these buckets are then bronze stainless steel hemispherical cups attached to the runner, that is onto which the water hits. The impact of the water on the surface of the buckets produces a force which causes the runner to rotate. Then comes the nozzle. So it is a circular guide mechanism for the water to flow at a designated direction. Then the water in the form of a jet is released from the nozzle, which then strikes the runner. The casing is generally made of cast iron. As I said, it protects the entire turbine from accidents or any external factors. Penstock is pipe through which the water having high potential energy flows from the reservoir into the nozzle. Then flow control needle, it's not exactly mentioned here, so but it's just you need to know it's a regulator or controlling device through which the water flowing through the nozzle is regulated. Okay. Yeah. So as I mentioned, the working principle I've already explained with the help of a diagram, and you can go through this notes for a little more details. And yeah, so the only thing probably something that I mentioned is due to the impulse action of water, that is the water from the nozzle which hits the buckets directly, it's called an impulse turbine. Okay, so let's move now to Francis turbine. Francis turbine is an inward radial flow reaction turbine under medium heads. That is, the amount of water that's stored above is a medium head water, and it's inwards. The water flows inward into it, and it flows in the radial direction. So previously it was in tangential direction in the previous case, Pelton turbine, and now in Francis turbine it moves radially and inwards. Okay, so that's the fundamental difference. As you can see here, it's in the radial direction and water flows inwards. Okay, so it consists of the guide blades on the outward part of the runner, and the moving blades are inside. So the water first enters through the volute, and then it strikes in the radial direction onto the guide blades, and from the guide blades it moves inward to the moving blades, and then the shaft is connected to the moving blades, or rather the other way around, the moving blades are connected to the shaft, and then the shaft rotates, and thus this causes the rotation motion, which eventually is used to produce the electrical energy. So this is the parts are few of the parts are similar to in all turbines. So one is the penstock, that is the long pipe which draws water from the dam or the reservoir into the turbine runner. Then the volute or casing, which is again which protects the entire turbine. That is, it's a spiral channel in this case with a gradual decrease in cross section area along the water flow direction. From the casing, the water gets distributed onto the guide blades. So then the guide blades are fixed vanes inside the casing. The guide vanes direct the water onto the runner. Then the runner is a rotor which the runner blades are fixed. The runner of the Francis turbine has passages. So these passages take the water. That is basically how the water moves inside. That is what is being described here. So it takes the water in the radial inward direction and then discharges in a direction parallel to the axis of the rotor. So yeah, so that's the brief explanation of the Francis turbine. So working principle, as in I've already explained it. So it's just the details of the same thing. So the pressure energy is converted to kinetic energy, and hence the water is directed towards the guide blades. So the water under pressure enters the runner from the guide blades is centered through the moving blades in the radial direction. And yeah, like I said, mainly it exits axial in the axial way, that is in a direction perpendicular to the shaft's direction. Okay, and as in all cases, the water is then discharged to the tail race through a draft tube. Okay, so yeah, that's about it with that. And now let's move to Kaplan turbine. Kaplan turbine is an axial flow low head turbine, and it operates entirely in a closed unit from the inlet to the tail race. So as you see, first it enters the scroll casing. There is a guide vanes there, but the water after entering that, it hits in a axial direction. You see the axis of the shaft, see the center part through which the about which the shaft rotates, that's your axis. So the water also directs and hits the axis, hits the blades in the axial direction, and then causes the rotation of the runner blades. And this rotation direction is again mentioned near the shaft, so it rotates, and then the shaft causes the kinetic energy being converted to rotational energy, which in turn is connected to a rotor, and the electrical energy is produced. Yeah, so the main thing is the placing of the guide vanes and the runner vanes here, which are different. So as you see, through the scroll casing, the water comes and it gets shifted by an angle of 90 degrees, and then strikes the runner vanes, and then after striking the runner vanes, it moves to the through the draft tube, it goes out and into the tail race. So the scroll casing here is what is the passage through which the water changes its direction. Okay, yeah. So before hitting the guide vanes, from the guide vanes, the water flows actually through into the runner. The guide vanes is to direct the water onto the runner. And the hub, the lower end of the shaft, is made of large and is larger than the other parts and is called the hub or boss. The vanes are fixed on the hub, and hence the hub acts as a runner. So the draft tube, as in the previous case, it's the same. So the water after hitting the runner and the blades, it passes out through the draft tube onto the tail race and goes out of the turbine. Yeah, so this is the big thing. So in each of these cases, make sure you draw the diagram right, and you give the explanation as the working principle, and mention the parts in brief, and give their explanations as to their functioning. So yeah, that's about it. So this completes your turbines. Thank you.